Hey guys, welcome back to another video. So here I'm going to show you guys how to differentiate the arcsinh terms, in other words the inverse hyperbolic sine with at the point x over a. So this one is a modified formula of the original arcsinh h, which you can find anywhere online, for example Wikipedia or various books. And in terms of logarithms, the actual function can be defined as this, as a log of x over a plus the square root of x over a squared plus 1. And this is, in my opinion, the most simplest way to actually start this off. You cannot actually directly integrate this, differentiate this, unless you use the inverse hyperbolic sine and cosine properties. But I'm going to take this method instead. Some things we need to know before we take this problem on. We need to know how to differentiate a log function, the natural log of a function, which is the same as 1 over that function times the derivative of the inside. So that's what we need to do for this one. You'll notice that the second part looks a bit complicated, but here we could use the chain rule to differentiate this by firstly letting u equal the function inside. Because remember, this is a function of function. And so by letting u equal that, we can say y equals all of this square root of u, which is just the same as u to the power half. So we can say capital Y equals arcsinh h, which equals a log. And using recalling the fact that the derivative of log function x equals 1 over fx, we can say that the inside function will be 1 over this. This is going to be the first thing you write. So we can say dy over dx equals 1 over everything inside here. Inside the function will be x over a plus the square root of x over a all squared. So I'm trying to be very careful here, guys. Times. Now we need to, notice here it says the derivative of the function. So inside the function, now we need to differentiate this. So first things first, looking at this head on, so we got x over a, differentiate x over a, we just get 1 over a plus. Now using the chain rule to differentiate this part, so over here I already said over this, I said recall we can use a chain rule to differentiate this term by literally letting the inside part, the square root part, inside the root to be u, because remember this is a function of a function. So if that's u, then therefore y equals a different y, the square root of u. And we know that the square root of u is the same as u to the power of half. I feel like I already just said this. And to differentiate u to the power of half is just simply 1 over u times the power of minus half. And this is the chain rule. Same thing here, to differentiate the y term, the original u term, this one, we could just expand this bracket. So this is x squared over a squared. So differentiating that, we're just going to get 2x over a squared. Easy stuff. So okay, and then to solve this completely, to actually solve it, now we just need to, the property of the chain rules are you just multiply the derivative of u times the derivative of y. So it's going to be 2x over a squared times half u to the power negative half. And this will give us our solution here. Notice that the 2 and a half will cancel out, so we'll be left with x over a squared times u to the negative half, and u is just simply the original term. So we could just say x over a squared plus 1 all to the negative half. And that's it, guys. So far we have differentiated. Now we just have to tidy this up. So what I'm going to do, I'm going to rewrite this part into fractional form. I'm going to get rid of all these powers. It's kind of confusing. So we're going to have 1 over the same term, x over a plus the square root of x over a all squared plus 1 times, now we're going to have 1 over a here plus, now ignoring x over a squared, the negative power here is literally the reciprocal. Yeah, it means 1 over this term, and half means square root. So it's going to be, let's leave x over a squared on the top line. The bottom is going to be the square root of everything you see. So x over a squared plus 1. Alright, almost there. Now, what do we do? Now, the next thing to do is to actually realize, is to tidy up the inside of this whole bracket. And that's by finding common denominators. So let's treat 1 over a like x over a squared. Let's treat it as a top-heavy function. So all we had to make this one fraction, we need to times up and down by this common denominator, which is the square root of x over a squared plus 1. So this means we should get the following. So I'm only going to work with the big bracket. So 1 over a should be like this. It should be 1 over a times the square root of x over a all squared plus 1 over itself. And you'll notice that if you add it to this one, plus this right hand side, so x over a, just a squared over the same function, we can finally combine it. So this is good. So combining this, you'll notice actually that this one looks very similar to this function here actually, except you got an extra a. So let's combine it and let's factor out the 1 over a. Okay, so if you factor out 1 over a, I'm just gonna get another pen actually. I'm gonna factor out 1 over a. So let's do it here. So we could say 1 over a goes outside, and we should be left with big bracket square root of x over a squared plus 1 plus x over a. And yes, you can see it's actually identical to this expression. Okay, all over the same term. So finally, let's write the whole thing neatly. I'm going to do it in one go. So this means this is what happens. So we're going to have equals 1 over, okay, let's get this right. So it'll be x over a. I can actually feel that it's going to be right. X over a plus square root of x over a squared plus 1 times, and then big bracket here. So 1 over a became, this all combined to make the same fraction. So let's put this over here. So it'll be square root of x over a squared plus 1. So that's the bottom. And the top, we said it was 1 over a times this term here. So it'll be, let me write down, 1 over a times, and I'm going to rewrite order. I'm going to put x over a first instead of this term. So yeah, plus the square root of x over a all squared plus 1. And now we can just cross simplify. So changing color pen, this cancels with this, and that's it, guys. We can therefore say that the final solution will be 1 times 1 over a over this term. So it'll be 1 over a all over the square root of x over a squared plus 1. And to make it look even nicer, we can drop the a on the bottom line. So it'll just be literally 1 over a times the square root of x over a squared plus 1. And if you had a constant for a, let's say if a was, I don't know, 4 or something. If a was 4, it could be any constant, then literally the solution would be 1 over, the derivative solution would be 1 over 4 times the square root of x over 4 squared plus 1. And that's it, guys. Hope this tutorial helped. This was a really long one, you know. But yeah, there's quite a lot of steps, and it's just a case of really absorbing it and taking as you go. Okay, so hopefully this was clear. And the key idea is to do a lot of manipulation, you know. But yeah, thanks for watching, yeah, and I hope you guys have a great day. Ciao.